Hello, everyone. Hello? 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 Yeah, I think Rohi is joining in. Let's wait. Uh, Hi, Rohi. I hope you
Hello.
can hear me, right?
Yes, yes.
Okay, give me 1 minute. I'll just share my screen. Okay, 16th of June, right? So, okay, fine. Yeah, so let me share my screen. I hope you can see it now.
Yes.
Okay, fine. So, let's give it a start. So before doing that, give me 1 minute. Let me just see why this thing is not working. Not able to type anything over here. Yeah, I think it is solved now. Good, good, very good. Fine. Okay, so let's start. So until yesterday, we have looked into the very basics of inferential stats. We looked into what we actually mean by the central limit theorem, the null and the alternative hypothesis, and so on. We looked into type 1 and type 2 errors. We have started taking a use case, but before that, we looked into the central limit theorem again. We looked into the empirical rule. We looked into the frequency table of how an experiment is going to be conducted. And then we looked into something, a concept like the confusion matrix, where we have seen the type 1 and the type 2 errors, right? Then we have started taking a use case. So this is from where we are going to continue. So I hope we remember the use case briefly. I have an apparel company which is already into Maharashtra. I would like to launch it into West Bengal. My product manager performs a survey in West Bengal for 400 houses randomly. Then she finds that the mean household income in those 400 houses that she has searched is 30,000 rupees per month, and standard deviation is 8,000. So the variation is quite good. Although I don't have any way to control the variation because that's not really in my hand, but it's good to keep that in mind. But during the exercise, or as we have already written down in the properties, I'm not certain about the specific value of the standard deviation, hence I'll only expect it to be as less as possible. So what I mean by that is, in case of hypothesis building or hypothesis testing, we're not really going to make use of the standard deviation, but mainly we will be making use of the mean. So our hypothesis will be basis the mean. But then when we are going to do the calculations, we are going to use the standard deviation, right, of the as is scenario that we have. Keeping this in mind, what my product manager says, she says we must launch in a state where average monthly income is greater than 29,000. Now, this is not the null hypothesis. The null hypothesis is actually the status quo, which is stopping you from doing something, which is like stopping you from making a change, right, in the environment. So that's why null hypothesis is mean is less than 29,000. We should not launch where mean is less than 29K. And alternate is where mean is greater than or equal to 29,000. As we have already discussed, null and alternate hypothesis must be exactly opposite, right, to each other. Now, taking this as the context, let's go ahead and let's see how we are going to solve this problem. Now, what we are going to do, we are going to draw a diagram. Okay, so we are simply going to draw the sampling distribution, and then based on the sampling distribution, we are going to do our activities, right? So let me see. I'll just increase the space over here so that I can draw. Yeah. So let's say I am going to draw it something like this. Let's say I'm going to take this as my x-axis, and then I have uh, a sampling distribution which looks something like this. Okay, so this is not really good, but it explains the point. So let's say this is my mean. Okay, so if this is my mean, then what I can say is that this value over here, right? This value is my mu, and I know that mu as per my data is what, 29k. So 29k is the mean of the data set that I have. So this is SS data. Hypothesis testing cannot be done if you don't have any background information, right? You must have some kind of a data. You must have. That data may or may not be telling you anything, but you must have some kind of data. Now, we will have to create something which is known as a point or a line on this x-axis. And this thing, I'm going to call this point, right? This point which is over here. I'm going to call this point, let's say, x bar c. Why is this x bar c? Because the value on this x-axis is actually belonging to any random variable x. In this case, it will be the salary, right? As simple as that. But this distribution is that of the sample means, right? So this distribution which I have over here is the sampling distribution, right? So basically, what I'm plotting over here is actually x bar, mu being the mean of that x bar. So that's the reason why I call this x bar subscript c. But why this subscript c is because this is my critical value. And I would like to define the critical value. Unless and until I define a critical value, I won't be able to know what I am exactly looking for, right? So critical value will be something, and we are going to find out what that critical value is going to be. So this critical value is going to be something that is basis the mu which I have, basis the standard deviation which I have, and so on. And then this critical value also represented as ZC, right? This x bar C, which I write over here. In many cases, in many contexts, or in many books, it will be represented as Z of C as well, without the bar. Huh? There is no bar. I'm sorry. Let me just remove the bar. Right. So Z of C is also known as the critical value of Z, or X of C is, or X bar of C is also known as the critical value of X bar. Now, basis this value, which we are going to calculate now because we know the formula for Z, right? We have already seen that earlier. What we are going to say is that this area, okay, this area which we have on the right hand side is my critical area, the area where I would like to test whether my data falls or not. Now, this will be confusing at first, but once we solve the problem, we will come to know what we are trying to do. Then if it falls on this side, then what we are going to say that I can safely reject the null hypothesis. Why is this the case? Is because this point over here, this ZC, defines a line or a boundary condition, which is also known as the confidence interval. Right? Anything which is falling beyond the confidence interval on the right side, or it is falling on the right side in the sense it is on the progression side. So we already know the progression is happening on this side, right? The progression of data is happening from left to right. So if anything falls on left to right or in the progression direction beyond the critical point, okay, then we are going to reject the null hypothesis. And that is the reason why this is my area of interest. Why? Because I have already told you statisticians or data scientists like us are always interested in this area, so that I can reject the null hypothesis and I can go ahead with what I think is the best. I don't want